In this one we are just going to estimate. We don't have the actual function here, so we're just going to estimate the values of these things. The domain, you can see this is going to go to the left forever and to the right forever, so the domain is going to be all reals. The range goes up forever. My upper bound will be infinity, but my lower bound looks like it's about -3. So I'm just estimating it. I'm going to call it -3 to infinity. Local maximum. This right here is your local maximum. It's not absolute because the graph does go higher than that, but it's going to be a local maximum. So I'm going to call that about, I don't know, 0.8, 8.2. So 0.8, 8.2. Local minimum. Well, we actually have a minimum here and a minimum here. Sometimes they're both called local minimums, but since this one is the lowest that the graph actually gets, we're going to call this one the absolute minimum, and we'll call this one the local minimum. So this one is right on 1, 0. This one looks like it's about -2.5, -3. And we're just estimating, we're just practicing naming what all the points are for this one. So that's why we're not being super technical. The equation in factored form, we can see 3 x-intercepts. But we know that this is a quartic, a fourth power function, because this one is bouncing off, which means it's got to have at least a multiplicity of 2. It's got to have an even multiplicity. So we're going to have 2 solutions here, a repeated root, one here and one here. So the first one here, if the solution is -3, that means that the factor had to be x plus 3 that gave me that solution. If the solution is -2, that means that the factor was x plus 2. And if the solution was 1, that means that the factor was x minus 1. But remember that that one had to be squared because it's bouncing off the x-axis.